Alright, so this is desperately unexciting, but, I feel like we gotta do it. Just a quick algebraic proof of variation of parameters and why it works. So this is kind of your standard form. So what we're going to do is remember that we take this and we turn this into a homogeneous equation. So we have homogeneous f of x, y homogeneous equals 0. Now we're going to pretend that z solves this. So z is some other random function of x that solves it. So that means that z prime plus f of x times z is equal to 0, or that z prime is equal to negative f of x times z. So we're just pretending that that's true. Okay? And so since it is true, then we're going to do our guess, and our guess is that y is equal to u times that homogeneous solution z. So I'm going to take the derivative, and I've got y prime is equal to u prime z plus u z prime. Then I'm going to plug that in, and I'm into my equation here. So I've got that u prime z plus u z prime plus f of x times y, which is u z, is equal to g of x. Now, u prime z plus u, now I know z prime is equal to this thing. U prime is equal to this thing, or z prime is equal to this thing minus f of x plus, f of s, z, sorry, z, plus f of x u z equals g of z. So u prime z minus f of x u z plus f of x u z. Look at that, didn't it? Just fantastic. Alright, so these two things here cancel out, which is kind of nice. So I've got that u prime z is equal to g of x. So u prime is equal to g of x over z. So basically you can solve from there. So that basically as long as there is a z, as long as z is like non-zero and exists, then you can integrate that and you'll always get a u that solves that little non-homogeneous linear ODE. So that's pretty awesome.